types of signals. Some sensors will send a digital signal, which is a square waveform, while other sensors can send an analog signal, which is also known as a sine waveform. In this case here, we have a wheel bearing from a vehicle that has a speed sensor. So your speed sensor in this case is a 2-wire sensor. This is a permanent magnet sensor that generates its own voltage based on rotation of the reluctor wheel inside. It will change polarity from positive to negative and generates a AC voltage, and it also generates a frequency. So with our tool, has a couple of adapters that we can attach to. One of our adapters using a banana connector. With our adapters, we're going to hook up to one of the terminals of the speed sensor, and the other lead will go to the second terminal of the speed sensor. Make sure the terminals don't touch each other, and all it's going to do is when the wheel hub rotates, the vehicle speed sensor will generate voltage. So when we select the scope setting on our V500, we press OK. You can select a vertical mode or transverse mode in your screen. We're going to select right now the vertical mode, and what you could be able to see on a sensor that you're testing, you need to know what kind of voltage the sensor uses. So you could select different voltage values. So in this case, we have 1 volt per division. That means this will add up to a maximum of 5 volts. Now, if we scroll the button up, it will give you a 2 volt per division to a max of 10 volts. Next one will 3 volts, maximum of 15. 4 volts, so every division is 4, 8, 12, 16, 20. 5 volts per division up to 25 volts, and 6 volts per division up to 35. And this will read to a maximum of 50 millivolts per division. So that you could use that to do injector testing. Fuel injector testing works up to that voltage value. Also, the time frame. You can select to on your buttons to scroll left and right. From 500 milliseconds, you could bring it down to 200 milliseconds, 100 milliseconds, 50 milliseconds, and 20 milliseconds. We'll bring it down. So it all depends. So let's bring it up to the highest scale for now, just so you can get a sense of that. You need to understand that the type of sensor you're testing with, you need to know the voltage value so you can have the right parameters on your screen, because this sensor will generate its own voltage. So if we rotate our screen so we could see this, and if we spin that reluctor wheel, there's a little change in our screen, but very little, because our voltage value is too high. So that means if we bring this voltage value to maybe a 5 volt per division, from 50 we bring it down to 25, and if we rotate, there's a slight change. We'll get our screen a little bit closer so you can see it, but also if we come here to a lower scale, we're going to select up to a 1 volt division. Alright, so we could get a better visual. We're going to set our tool right here on top using this top here. We have selected a 0 to 5 volt scale. The time frame sampling rate is 500 milliseconds. So we rotate this. You can see something changing on that screen, but not as a good waveform that you would like to see. That means our sampling rate is too high, from 500 milliseconds. Let's scroll down to maybe 100 milliseconds. Let's try 100 milliseconds. As you can see, there is a difference on that waveform. So if we get a little bit closer, you can see that it's switching up and down based on rotation. The faster I rotate, the higher the frequency. And if I stop, it will stop giving our rotation. If it's a constant rotation, you're going to see a constant voltage. If we increase, it will increase its frequency. So if we go to a lower sampling rate to maybe 20 milliseconds, and you can see the difference here. As you speed up, you get a higher frequency. And this sensor, it has a certain amount of teeth on the reluctor wheel inside the hub. So that means you want to see the same distance from each of the spikes going up and down, because you have you're looking for a specific pattern which should be consistent in here. So the sensor, it's capable of generating voltage. This is a permanent magnet sensor, so you'll be able to see that only based on rotation this sensor generates its own voltage. What type of sensors can you use for doing some of this tests? You could probably use in this case, a speed sensor. You could use a camshaft or a crankshaft speed sensor that are permanent magnets that they generate their own voltage. So you can use this tool for purposes like that. So, all right, so let's use the V500 Pro, the scope part, just to check a sensor. We're going to check a camshaft position sensor. If you come here and select the scope, I have the cam sensor back to here using one of the adapters that the tool comes with. I'm piercing the wire. The wire was kind of hard to back pro, so that's where you have those type of adapters. And these type of sensors are Hall switch. That means we're going to get a square waveform. So if I select scope, I should see a square waveform. I could select a vertical view, if that's one way to check it, or I could escape and select the transverse view, scroll down, select OK, and then you could get a scope sideways. Now when you're checking this, you got to keep in mind that you have a sampling of a certain amount of time frame and voltage. So I'm on a 2-volt square division. If I switch it to a 5-volt scale, which is 1 volt per division, and I could come here and change the time frame. That's 1 millisecond, 2 milliseconds, until you get a nice waveform. That's where you use the time frame. That's 10 milliseconds view right there. Now that pattern is going to be different on every car. The pattern is going to be based on the design of the reluctor wheel. That's where the pattern would change. So this is a perfectly working sensor. It's a nice square waveform, and there are no glitches, no dropouts. So this is great for this tool. You get a nice scope on your Logic Pro. It's nice to see to have all the features in one single tool.